Welcome back, Math 30-2, to your fourth lesson on permutations and commutations. In this lesson, we're going to learn about permutations with repetitions. So what is that? Well, it's kind of like this here.
Lewis, Mom, Mommy, Mama, What? Hi.
So instead of it being long and annoying like that, we're just going to find ways of using permutations to help us solve repetition problems. So let's go ahead to page 89 in your book. Alright, so here we go. We're looking at find the number of permutations for the following words. Okay, so here's our formula for repetitions, and we're going to try and use that to help us with this. So it says, for the word Vancouver. Now I look at Vancouver, I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 factorial, okay? But now, how many of these are repeated? I have 2 V's, right? So that's 2 factorial. Do I have anything else? N, no. 1A, 1N, 1C, 1O, 1U. Okay, so it's just 9 factorial divided by 2 factorial to give me that answer, which will end up giving me, once I use my trusty calculator, I go 9, math over, factorial divided by 2, math over, factorial, and that gives me 181440. Okay, let's take a look at the next one. We're looking at mathematical. So this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 factorial. Okay? Now, what is being repeated here? We have m is repeated twice, so that's 2 factorial. What else is being repeated? I look at my a's. I have 2 3a's, so that's 3 factorial. Okay? Now, what else is being repeated? I have, just wait, 2 t's. That is 2 factorial, and anything else? That is it. So I just divide by the repeated things. So we don't have to look at it, and it's not that long and complicated, it's just this. That's it. So when I plug that into my calculator, I'm going to have to go 12 factorial. Oops. Go over math, 12 factorial, and we're going to divide it all by all of this here. We want all of that. So I have 2 math, go over, factorial, and we have 3 math over factorial, and I have 2 math over factorial bracket. There we go. And I'm going to get a total of 1995840. And that's it. Okay? So it's not that bad. These represent the repeated numbers. This is everything together. This is the things being repeated, or the items, the elements being repeated. All elements being repeated on the bottom. Now, here, the m's are different than the t's, which are different than the a's. All of them are different, so they need a separate entity for each one. Let's take a look at example number 2. It says, Brett bought a carton containing 10 mini boxes of cereal. Okay? There are 3 boxes of cornflakes, 2 boxes of Rice Krispies, 1 box of Cocoa Puffs, 1 box of Shreddies, and the remainder are Raisin Bran. Okay? So there's 3 cornflakes. Okay? There's 2 Rice Krispies. And we have 1 Cocoa Puffs, and we have 1 Shreddies, and the rest are Raisin Bran. So that right there is 5, 6, 7. So then there's 3 Raisin Bran because there's 10 altogether. Now, I look at this, all together I have 10 factorial. All the elements together, we have 10 different cereal boxes, right? Now, a lot of them are being repeated. We have 3 CF cornflakes. We have 2 RC Rice Krispies. Oh, that's an RK. Rice Krispies. And then we have 3 Raisin Bran. Okay? I could put the 1 factorial. The 1 factorial is just 1, so that's kind of like a waste of work and effort. So now I plug that all into my calculator, and I'm going to end up getting 15120. Okay? There we go. So that's not that bad so far, is it? Pretty simple. Just we take a repeater and we go over. Now, we're getting into something here a little bit more interesting. Oh, I love these. This is pathways problems, kind of like puzzles. Trying to solve for the puzzle, or in this case, the pathway. All right? Now, we want to find the number of roots. So if I was to try this, it would take forever. Right? There must be a shortcut. I could go, here's one root. Right? Here's one root, 2 roots, 3 roots, 4 roots, and it would go on forever and ever. We could find so many roots, it would take a long time. The easy way of doing this, there's 2 ways of doing this. We could do it using patterns or permutations with repetition. So here's my first class example. If you go over this, you'll see what we do, and I'll show you here. If you went over the page before, it tells you what to do, but I'm just going to go over it quickly here in this one. So, using patterns. So basically, if I keep on going this way, we can't go backwards. Like if I want to go from the bus station to the concert hall, well, I'm not going to go this way, then back up. That makes no sense. I'm on how many fast routes are there without backtracking? Well, to get to here, there's only one way. We can only come there. To get to here, there's only one way. Through here, and then here. Right? To get to here, there's only one way. Through here, here, and here. Now, to get to this point, there's only one way. Straight down. To get to this point, there's only one way, which is straight down. Because I can't back up that way. This one as well. One way, and this way here is 1. Okay? There we go. Now, to get to this point, I could have either come from this way or this way, which gives me 2. I add those 2 corners together. To get to this point, I could either come from this way or this way. Now, I'm looking at that. There's 2 ways here and 1 way there, so that gives me 3 ways to get there. To get to this point, I could either come down from that point or that point, which gives me 4, and this last one's going to be 5. So I'm going to continue this here. So to get to this point, I could come down or across, which gives me 3 different possibilities. To get to this point, I could come down from there, which is 1 way, or come from this point here, come from here, which is 3 ways, or this point here, which is also 3 ways. So that's a total of 6 different ways there, right? Because 3 ways or 3 ways. Every time we say or, it's adding, so we can come from here or there. Come from here, I have 6 or 4, which is 10 ways. Here we have 15. Okay, let's continue this. And we have here, there's 1 way or 3 ways. So that's going to give me 4 to this corner. Now let's take a look at this. We have 6 and 4, which is 10. Here we're going to get 20 and then 35. Hopefully you're getting that. Now, to get to this point, I could only come from there, can't I? And there's 35 ways to here, so then to get to that point, there's still only 35. To get to this point, there's 35 ways to that point, so there's only going to be 35 ways to get to this point. Because the only way I could get to this point is through that point. Now to get to this point, it's going to be a bit more. I could come from here or here, which gives me 70. To get to this point, there's only 35. To get to this point, there's only 35, because I can only come from there. Now this point here, I have 105. This point here, we could come from there or there, which gives me 105. And this last one gives me 210. Okay, so using patterns, there's 210. That takes a long time, doesn't it? There has to be a shorter route. Well, I look at this, think of a repetition. I could go 1, 2, 3, 4, 1, 2, 3 to the side, right? So altogether, in this first one, we have a total of 1, 2, 3, 4, 1, 2, 3, and 1, 2, 3, 4, which gives us a total of 7. Factorial. We have 7, we have 3, we have to overall make 3 moves to the side and 4 moves down. The order matters, like they're different routes, right? We have 3 to the side and 4 routes down. So that's how we have to do it. 3 side, 3 down. Okay? Because we have side and then down. So we have this way plus the down on top, right? Now, what is my repetition? Is down factorial and side factorial, because there's a repetition. So that's 3 factorial and 4 factorial. I have a total of 4 going down and 3 across. So that's 4 factorial and 3 factorial. Okay? Okay, so let's take a look at this. Now, that's just to get to this point. So we have to do this, and then we must do this. So let's take a look at this one. Altogether, we have 2 down and 2 aside. So that's 4. Altogether, we have 4 elements altogether. 2 aside, 2 down. We have 2 down, so that's 2 repeated downs. And we have 2 to the side, so that's 2 of them or the sides are repeated. Now, all I have to do is I have to multiply this here together in my calculator. Okay? And when I multiply this in my calculator, I'm going to get the same things I have there, which is 210, which is actually a lot faster and easier. Now, let's take a look at question number 4. Okay? It says, a taxi company is trying to find the quickest route from the train station to the football stadium. Now, use the pattern to determine this one. So once again, let's put in 1, 1, 1, 1, 1, 1, 1. So there's only one route, one way to all those places. This one here, we could come from there or there, which gives us 2. Here, we could come from up here, down, or there, which gives us 3 routes. Here, we could come from down or across, which gives us 4. And here we can come down or across, which gives us 5. And here we're going to get down from there, which is 1, and 2 is 3. There's 3 routes to get from there, 3 routes from there, which gives me 6. 6 and 4 is 10. 10 routes and 5 routes is 15 routes. And then here we go. We have 1 and 3 routes is 4, 10, and 20, 35. But now, to get to this point here, it's a bit different, isn't it? Because there is 4 routes to get there. So here, there's 4 routes, right? Because I can't come up or from anywhere else. I can only come from that point there, which is 4 routes. So there's only going to be 4 routes. That means to get to here, we have 4 and 10, which is 14. Then to get to here, we have 14 and 20, which is 34. And then the last one, to get to here, well, not quite the last one, to get to this point, we're going to have 69 ways. Now, this last point here, to get to this point, I can only come from this 15 routes, can't I? So that's 15. I can't come from here, I can only come from there. And you can't go across, because that's running into a house or something, or building. I'm not Superman or anything like that. I can't storm through buildings, okay? Now, so this point has 15 and 35, which gives me a total of 50 different routes. So 50 plus 69 is going to give me a total of 119. Okay? So there's 119 fast routes to the football stadium. They'll backtrack. Now, next part here says, explain why 9 factorial over 4 times 5 doesn't work. Well, if I look at this, this isn't a perfect square, is it? If I look at this, we have 1, 2, 3, 4 repetitions, but then we have a repetition there as well. But this repetition isn't the same as that. I have 1, 2, 3, 4 going to the side, but this repetition isn't the same as that. Therefore, this cannot work. It isn't east, 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 and then south, 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 south. It doesn't kind of work that way. There are those, but there's these squares missing, so it cannot work. Okay? Does that make sense? So hopefully you understood that. If you have any more questions, you could talk to me tomorrow. I kind of skipped these ones here, but hopefully you understood that by me doing this. This is the first section of 1. So if we just finished there, it would have been 35. And just like this one here, I just combine them. Okay? So, hopefully you understood everything. Good luck, as I see you tomorrow and we work on this together.